JT, you're still muted.
I'm sorry about that. Let's start again. So thank you guys for joining for Tech Tuesday. I do appreciate everybody jumping on. Before we get started into today's presentation for our second part of Collaboration for Success, I'm just going to do a quick mention of CRMCA membership if you are members or not. There are some major benefits to be part of the association. And really just getting your voice out there with the membership and helping out. And if you do want to get involved a little bit more, do reach out to me via email through to get connected to the technical committee, where we do talk about a lot of the regular stuff going on throughout the Colorado industry. Partnerships with CRMCA, ACI certification, as well as CTAC, and making sure that we're all on the same page. So with that, we are here for Tech Tuesday. Tech Tuesday was really built to be a series to address ongoing changes in Colorado and really sharing the knowledge of our professionals and industry experts. So that is what are here today for. And we did have Collaborating for Success Part 1, Setting the Pace Through Project Responsibility, a couple weeks ago. And both Mike Eads and Robbie Lewis did present on that part. And if you guys did miss that part, do scan that QR code that's on the screen. And that'll link you right to the YouTube video for Part 1. But hopefully you did catch up already, because we are now on to Part 2. For our presentation, and that is navigating field challenges. We're going to be talking about more of the items that are happening on site. And it's like, what's going to happen, and what do you need to continue the planning once you're on site and that team has already started on a project. So with that, I'm going to hand it off to Mike Eads, Robbie Lewis, and Mike Hernandez with the ASCC to introduce themselves and really just take on the presentation. But understand, this is a conversation more than a presentation. So I am going to give you guys access to unmute yourself. Please do if you have a question. Don't hesitate to interrupt these guys. They have given me authority to allow you to do that, to have the conversation. Let's ask the questions right away instead of waiting until the end. So have that conversation. Let's talk about it, and then we can continue on from there. So with that, I will give the control back to you guys, and you guys can introduce yourselves and get going.
Right on. My name's Mike Eads. I've been in the industry for 20 years, 16 of that as a contractor, 2 years as a precaster, 2 years as a ready mixer. And I'll be speaking, I guess, on the point of view of the general contractor and the concrete subcontractor on this one.
Robbie Lewis, United Company's Ready Mix Department Manager. I've been in the concrete industry for about 25 years now. I also started in precast and have been at a concrete producer for most of my career in kind of all lines: sales, operations, dispatch, and now I'm in just over operations for Western Colorado.
I'm Mike Hernandez with the American Society of Concrete Contractors. We're a national trade association, but I do live locally in Parker, Metro Denver area. Started in concrete construction in the mid-90s and undertook this role in 2023. Let's see. So I'm going to this out with a safety moment. ASCC typically begins our meetings with a safety moment, and this one's a bit sobering. Unfortunately, the construction industry has a suicide rate that's the second highest among all industries. Only the mining industry in the south at this point. It's an infamous thing to have. Craft workers are 5 or 6 times more likely to die from suicide than at work. And we do have some resources here, some websites, and the 988 is use phone or text. I've seen hard hat stickers for that to increase awareness that there are tools available. So, thing that happened that was a little surprising, a little over a year ago, ASCC got a call from NPR asking that they had received an anonymous call asking if concrete is still a material that they can trust. And we talked to them for a little while to figure out what the heck they were talking about. And they were saying that there's new cement out there and people don't know what it is. So I clarified, well, it is new, but we went through a lot of technical discussions about it. And then finally I just said, here's the best analogy I can give you if you're trying to talk to a non-technical audience. Let's say that you've been bowling your whole career and you're getting pretty dang good at it. So good that it's almost like you're not standing at the regular normal bowling line. You walked 2/3 of the way up the alley, and between mature cement, ready mix producers that have been making the same mixes for decades, and this is the only material that concrete contractors know. It's like you're bowling from 15 feet away. You're getting strikes every day without too much effort. You're not even paying attention. You're getting expected outcome. But now we have a newer material. So it's like you walked backwards to open up the possibility of getting not what you expected. Really, if you're changing aggregate suppliers, if you're changing all your admixtures, this is a process of transition that can happen really it happened with 1L for sure, but it really could have been any major material change. So change, and then you add in high evaporation rate location or climate like we have in Colorado, and now you have opened up the possibility for getting more unexpected outcomes. But a seasoned professional can still put one down the middle every day. But basically, that's why someone was compelled to get NPR involved. But by the time we got to that explanation, they're like, "This is not a national crisis. We're just okay." And I did clarify that. Okay, once you start working with the material, provide some feedback to the ready mix producer about what you like or don't like this new mix, and that contractors use some different methods. Then really, it's like you step walking back up the bowling lane again, and it's not near as hard as it seemed like it was the first time it came down the chute. So.
Nice. So kind of morphing into that. So just talking through these slides, if you remember from our part one, we're now going to jump into some common issues that we see on the job site. So this is what you're doing to make sure that you're prepared. So the contractor is usually taking the lead on this, and we are coordinating with the finisher and the ready mixer. We're kind of the collect-all that's acting as middleman, talking between these trades and trying to clear everything up. So there's certain things that we are planning for that we start rolling in the subs at this point when we start getting on projects. So the poor planning phase things we want to make sure that we're aware of is the subcontractor ready? And this can entail a lot of stuff. Are the submittals in? We recently found out through calling all of our rebar suppliers, we used to have a lead time of 5 days for rebar, and that has grown to 10 to 15 days in the last couple months. Post tension's even worse than that. So are your subs ready? Have you notified them to make sure that they know when they're starting, when the job's going? And part of a contractor scheduling is putting on long lead items, and you put on material procurement. So that should be on a log within your schedule before you show your construction activities. It says, roof material could be 36 weeks out. Elevators could be 24 weeks out. And then you've got, in our world, it's not as critical because we have the luxury of our mine materials are in our backyard, so to speak. But through the mills and things like that, we're starting to see longer lead times. So another thing is a lot of engineers and architects are requiring at least a minimum of 10-day review for drawings, specs, and any kind of submittals. So if you're changing something or you're submitting a product that varies from what the drawings or specs say, which oftentimes is the case, we tend to use products that are readily available for us, something that we have experience with, and a lot of our specs and drawings can come from out of state. If the engineer is not in Colorado, They will pull from what they know in their market. And oftentimes there's incompatibility with that, where they're saying use this chemical that's readily available. And for Colorado, it may be a 2-week lead time to get the product, and then the trades have never used it before. So there's always that mix and match that you have to get through. Mock-ups, Mike and I are both going to go into this in detail. I live and die and swear by mock-ups. It's a small insurance policy to make sure you know what you're doing. And this will help alleviate some of the type 1L that Mike was discussing in his previous slide. Is now that the bowling pins are much farther from where you're throwing, what do you have to do to hit dead center of that? Mock-up can certainly assist in that, because your finishers, your pumpers, your ready mixers are getting a feel for what it is before you hit the big leagues, so to speak. So before you're pouring a 120-foot long wall or 15,000 square foot slab, you can do a little trial and error, and you can tweak things prior to that point to make sure you're saying, hey, the mix is a little sticky. Hey, we're seeing early cracking, whatever it may be. You can make those adjustments before it's prime time, so to speak. I've had this one. I actually had this yesterday, where I got a panic phone call. Hey, we just poured a pit down in a wet area. Who's cutting the control joints and what's the layout? And I go, well, there are none. We put it on there on the drawings that we submitted, but it was technically a footing, but the superintendent misunderstood it as a slab because of the size of it, and called a panic and created a frenzy. So my fault for not making sure that T was crossed and that I was dotted. But you encounter things like that, so it's just making sure that you're doing your best to think of everything. Reinforcement, I've gone over this in previous presentations that I put on, where as a contractor, I like to pre-tie things. The more I can prefabricate, it makes everything easier in the field. So I just connect Lego pieces, so to speak, instead of freestyling stick by stick. So there's opportunities for that, and that's something that you need to discuss with a rebar installer, or even precast. If you're doing precast components, what pieces do you want prefab and connected, or what parts do you want connected ahead of time that you can set it in one shot? Talking through weather contingency and emergency bulkheads, today's a beautiful example of that right now. We are getting about an inch of rain today, so my job sites are flooded. I've got 2 that are basically raw dirt right now, so my concerns are the general contractor has come to me and said, we're getting trucks in first thing in the morning, we're going to pour and pick right back up where we were. Well, we can't do that. I already had that discussion this morning that we need to do a late start. Reason being is I have to make sure the dirt guys can get paths throughout the job site dry, to where if I bring a ready mix truck or a pump truck in there, I can get it in with all that weight on it. I ain't getting it out once they're empty. And I'm going to make an awful mess on the city streets, which will violate my stormwater policy. So things like this is today would be a perfect example that can make tomorrow a pretty rough day if you don't have a plan in place. Emergency bulkheads, if you did happen to get caught pouring this morning, and then all of a sudden the sky opened up on you. This is something that we went over in part 1 in pretty extensive detail, was knowing what you're going to do in those situations. If halfway through a pour, the weather flips upside down on you. And in Colorado, we all know clouds can roll right over the hill, especially in Robbie's market in the mountains. He's surrounded on all 4 sides with bad weather. So it's just having that contingency plan and knowing what you're doing there. Something that a lot of people don't think of outside of the finisher per se, and this is something I've had to learn a couple of times the hard way, is slab thickness changes or differential curing. Let's say I've got a 5 to 8 inch thick slab, and then all of a sudden in the middle of it, I've got a thickened edge where they're going to put a masonry wall, or they're going to put some kind of steel structure, and they need a room for the anchor bolts to be down the concrete. Now I've got a portion in the middle of the slab that's 2.5 feet thick. That is going to stay wet while the rest of the slab dries out. And now when that thick chunk of concrete is starting to dry and it's pulling inward, it has no choice but to pull from the hardened concrete that's thinner. And all of a sudden you're going to get those 45-degree cracks tapering off of that thicker portion. So it's understanding, maybe it's something you discuss with the engineer where you got to fill that thickened area first. We do this a lot with PT beams, where you pour it and then you do a topping over it. That just helps with the differential curing, something to discuss. And then we'll get into cylinders and curing quite a bit. I don't want to steal the thunder there, but we had the discussions on the 2 jobs I just started for, hey, the cold season's coming, so the tanks are going to change. You know, we're going to go from hot to cold. And this time of year, it could be day by day. You could be 90, you could be 50, back and forth. So do you have a plan for those tanks and how you're going to cure your cylinders? Issues that arise, these oftentimes happen at the start of the job and you hope to catch them ahead of time, but this is something for everybody to consider. Changes to mix designs, size of aggregate and admixtures. A lot of times it's the contractor who's guilty of doing this, and I'll explain why. So oftentimes I will request a pea gravel mix. I need something that my crews can lift on their shoulder, because I am coming into a finished building and having to pour things that happen after the fact. It could be ADA ramp walls. It could be curbs. It could be I'm filling bollards inside somewhere. DIA, I had to do column wraps that were in the middle of the building. So I had started with 3/4 to 1 inch aggregate standard mix, something that I can pour with a 4 or 5 inch line when I'm doing big concrete pours. Now I need to get more precise. I'm sneaking line into a building that's basically finished, and then I have to have my crews pick that hose up on their shoulder or hang it with a candy cane that they can support it. Either way, they're lifting it off the ground, either over their head or at head level. A rule of thumb that I like to tell everybody is, once you hit a 4-inch line, if you've ever had the pleasure of shaking one of those 4 or 5 inch lines out, you'll need a couple of guys to shake a line out with that much diameter on it. It's heavy. So to prevent anybody from getting hurt, 3 is usually the starting point if we are going to manhandle something. I prefer a 2-inch line, but I also drive the ready mixer crazy when I start requesting skinny lines like that. We're really pushing the envelope. So 3 is kind of the magic number, but a lot of times it's the contractor will make these decisions in a bubble, and maybe we tell the ready mixer and then we don't tell anybody else. And then the finisher's going, what the heck? You know, what are you doing here? Or some other trade could have an issue with that. And then we may have admixtures for aesthetics is kind of our world. You know, a lot of testing revolves around strength, air, and slump. Mine may be the look. An architect might come in and say, hey, this wall has a reveal and tie hole pattern. I need this wall to look nice and uniform and slick. Now all of a sudden we're introducing admixtures simply for that reason. It's not that the mix isn't good enough. We just have to make it look a little slicker. So that's definitely something that can cause chaos. And oftentimes we don't communicate it soon enough. We will usually get in our meeting that week, and then we're calling the ready mixer going, hey, help, you know, we need to do something like this because it's a goal of the owner, or something that is a sticking point on the job site. This one comes up. Does everybody know the slump and error of the mix? And the one where this bites people is unseasoned contractors who review mix designs. We had a job, and this wasn't with my current employer, it was with previous ones way back in the day. We had a air mix get into interior slabs, and my finisher hit the panic button, and rightfully so. He's going, there's air in this. I can tell by the way I finish it. We're going to get blistering. We're going to get delamination. Sure enough, we did in certain spots. They did their best to try to fight it, but it was too late. You know, we it was roughly a 40-yard pour, but something like that, just that inexperience. So does everybody know the slump and air and where it goes and why it goes? You know, why would there be air in an interior mix? Should it be on the outside? Those kind of things, just making sure when you go through your pre-construction meeting or your submittal review process, that stuff's being caught. This one, and I don't mean to steal the thunder from Mike, but this is something I have to be aware of in the contractor world along with the finisher is cubic yards per hour. I'm a big production guy, so I need to make sure that Robbie's crews know how many trucks per hour they're going to be producing and sending to Mike, who's going to be placing the slab. And he's going to be putting it down at a certain cubic yard per hour. And this usually what I see is, everybody feels a lot more comfortable the thicker the portions are that we're putting flat work on. For the finishers, they can volume dump, they can take a lot more cubic yards per hour because they have to fill that mass up before they actually get to the part where they got to finish the top. When you're in a much thinner application, this should make everybody a little more nervous. If you're doing a 5-inch thick slab, but you've got 15,000 square feet that day, the first question I'm asking not only is how many cubic yards per hour can you do, what's your crew mix for your finishers? Do you have a good mix of finishers versus laborers? It's not a half and half in that case. You definitely need more finishers than laborers versus the thick one. You're going to need a lot more laborers because you're going to be vibrating most of the time, and then you're going to be finishing a relatively small area as you continue to fill that mass. So a crew mix and knowing how many men are on that crew for the finisher also translates to how fast the trucks are going to arrive on the job site. And then as a contractor for ingress and egress, I need to make sure I can feed that. If they say 80 yards an hour, which is a pretty common rate when you're doing fast slabs, is can I get my trucks in and out? Can I drive them through the job site? Do I have to 3-point turn them? Do they got to back in from a 4-way intersection in downtown Cherry Creek and back up an entire city block? I know that's oddly specific because I'm dealing with it right now. So those kinds of things are that all three of us will be in play on that. That affects all of us. And if one thing goes wrong in there, whether either the contractor didn't figure out the right rate, the finisher got overly confident, or maybe they had a field issue where they have to slow down, affecting the ready mixer who's already batched 6 or 8 trucks in 30 minutes and on the way. It can bottleneck very quickly with a not proven plan. And then I want the finisher to come out and walk my jobs. I require this. So oftentimes it's in the finisher's best interest, and I know it's hard for them if they're usually booked all week with pours and they are overseeing the pours in the morning. They're lucky to get away in the afternoon if they can, but they need to come see the pour, and there's several reasons for this. Where are we loading trolley machines on the slab? Can we load them up? Is it an elevated deck? How do we get access on? Which direction is the finisher going to finish in? Because they need to get their crew off the deck. So you can't finish to a building edge that doesn't have any stairs. Those kind of things. And then you start getting into, dang it, brain fart. I had such good momentum, and then this damn getting older. So basically, it's all those things you got to think of, and it's just you got to have equipment, how you can pick that stuff on and off, how you drive your trial machines off, how you're going to cure the thing. You're going back out there, and are you spraying as you go? Do you have a wet cure system that you got to turn on? There's a whole logistics thing, and then for the finisher themselves, why I like them to walk the job is rebar congestion, especially in post-tension applications. Corners of slabs are absolutely atrocious with this. Engineers will design corner bars, hook bars, backing steel or bursting steel for PT, and then that's where all the heads of the cable are too. And to boot, there's usually a column there. So now you have column reinforcing sticking vertical out of there. So if that finisher doesn't give input, having done this for a long time now, I recognize those areas of congestion, and ahead of time, we're already bundling rebar, getting that approved with the engineer to create bigger gaps. This is something where I may have to go a 3/8 pea gravel mix, or I may have to do some kind of pour ahead of time. But what I'm trying to do is clear that up, but the finisher will know better than I will. They'll know, hey, I have to bring pencil head vibrators, which is a 1-inch vibrator, to sting in these small gaps in order to get proper consolidation in there. Or maybe I have to pile the mud on one side not power shovel, but I got to vibrate and drag in order to get everything down in there, because you're going to really need to pack these areas of concern. So there's a lot of things. A finisher coming to the job site will make a world of difference. I wouldn't discount a guy like Robbie or one of his operations guys coming out there. We usually do this with the pumper and the ready mixer. They have their own kind of separate walk. And we kind of do it one time at the start of the job. Hey, here's what we're thinking of bringing your trucks in. Here's where we're thinking of staging. Here's how it's going to track. And then you may go over if the plan on the construction side is going to change, because your logistics plan in phase one might be just fine, but especially in high rise, other trades will start to come in, like the mason or the curtain wall, steel, and they want to take the area that you had staged for your trucks. So now it's all out the window. And when you hit phase two, they have priority over the concrete guys. Testing. So how many sets per cubic yard? I deal with this on jobs all the time, whether it's you have to have one set if it's less than 50 yards, or when you do slab pours that are substantial, you're testing every 100 yards. I've seen on really big pours where I'm approaching 1,000 or higher, they up to 150 or 200 yards is what they want to test and make cylinders, because the sheer volume that we're doing, we would need 10 coolers and 10 horse tanks in order to hold all the cylinders if we did it every 50. So there's variability based on what you're doing and getting that engineer buy-in for the team. But everybody needs to know that, including the tester, what they're up against and how frequent they got to go. If you're using multiple pumps, maybe you have to have a tester on opposite sides. There's that possibility as well. The type of curing, are you dealing with wet cure, spray cure, whatever it may be, having a plan for that. If you don't have that plan, what'll happen is that when all the concrete's down and finished, that's when everybody starts asking the questions. Well, what are we going to do here? And it's way too late at that point. And then, does everybody know the floor flatness and levelness requirements? This will attack the finisher's scope of work more than anything, but FF25 versus FF50 is a whole different array of finishing and machines when you're dealing with those different kinds of systems.
So kind of tagging on to a way to resolve everyone's expectations. Here's a QR code for the CRMCA ASCC pre-construction checklist. I believe CRMCA also has one of these. Some of the controversial things are, can anyone add water on site, or is it only the superintendent? And that presumes that they've looked at the batch ticket and know how much hold water they have to work with. What do we do if slump or air is high or low, and test it again? Do we test the middle third of the truck, which is actually the standard? And things like, how much time do we have to discharge? That should be resolved ahead of time. Worked on projects that were well above Keystone, and the load-out time from Silverthorne up to that project was pretty substantial. So there was set retarders to make sure that we could still place it when it was finally up there. So a whole lot of stuff. There's a extensive checklist to go through on the pre-placement meeting. Was doing a presentation in Indianapolis last week, and the consensus of the room was that was one of the most important meetings in the entire job site to make sure everyone's in alignment.
Yeah, I think, we talked at the last Tech Tuesday about how important it was for the pre-planning, the pre-conversation, right? That let's get in front of this. And as you guys were going through the list of all the issues that can arise, I was going through my head thinking about how many of those things happen at the time of the pour, right? The first two trucks are already there, and now we need a 3/8 mix, or what's the slump target? And then I started thinking in my head, how many of those issues arised in the last month for me? And it was several. And then I got to thinking, actually, a couple of those happened just today. And I think that's the intent of this conversation is, as an industry, how do we get that to stop happening, right? Like the slump thing just happened today. We were in the middle of a pour and everybody's looking at the ticket. There's water to be added, so pumps adding water, but we're exceeding the slump specification now. It's like, well, everybody needs to get on the same page here. And really, we've got to just get better at having that established before the pour ever starts, right? So when I was building slides for today's conversation, I was really thinking about what are the things that happen the day of the pour. We talked about pre-planning, and hopefully this can be a little bit of a list for some folks to take back and when they're doing that pre-construction and have some conversation about, well, have we addressed this? Because that's the only way we get better is by having this stuff done ahead of time. So from my perspective, right, we're talking about job site planning, and Mr. Eads already talked about it, but the traffic pattern is one of the things that I feel like is always overlooked is how are we getting these big trucks that don't turn well in and out of here? And where are we turning them around? Where's that washout going to be? And that really needs to be established before the day.
Probably on that note, if you need flaggers, who's providing the flaggers?
Yeah. Yeah.
Was it the place finish guy, the concrete contractor, the GC owner? I mean, who's making sure that the traffic doesn't get caught up in the middle of you trying to pull out and back in?
Yeah, and it's not the ready mix driver in his vest is not the flagger, but oftentimes we get asked for that, right? And again, I think as we talk through this, how many times does that happen when the trucks arrived and then we don't have anything in place? And that's what we've got to get better at. So traffic pattern, that's an easy conversation to have up front. The problem that I see with that is, like Mike said, we'll go to job sites at the beginning of the project, but that will change throughout the project. The traffic pattern will change, and not only necessarily with the project, but even with the placement method, because if we're crane and bucketing, we're going to be over here. If we're pumping, we're going to be over here. Are we getting 2 trucks to the pump? And really, so that conversation almost needs to happen every time an order is placed, is what is the traffic pattern? And that's what I try to encourage my team to ask that question every single time we get an order. And what we need as an industry is we just need to give the time that it takes to figure that out before the trucks show up. We frequently feel pressured to get off the phone in the dispatch office when we're trying to get an order, and the concrete guy has a million things going on, but I need to know all of this information. I need to know the mix and slump and error, but I also need to know how am I coming in, what's the intervals, all of those things. And sometimes we lose sight of that and we call when it's convenient, but we don't really have the time to do it right. So I see those things regularly. We just recently had a placement going where we were halted because we were setting steel and we were swinging steel over the top of the ready mix trucks, and that's a no-go for me, right? So we're gonna go ahead and leave now because it's not safe for us to be under this live load, and that's a bad day for everyone, right, Mike? That's gonna ruin your day if I say I'm leaving because you guys are hanging steel over top of our heads. And again, that's not a problem we should figure out when the trucks are there. Like that's a conversation that we can have well ahead of time. And what are the other trades that are working and what's the space that they need? And how's that going to impact all of us? And then the last thing, really focus on the job site that I got to thinking about is Mike talked about what happens when weather moves in, more from a contractor focus of where's my emergency bulkhead? How am I protecting the slab? And immediately I'm thinking about how am I protecting my trucks? A good example of that is we were pouring some ski lifts, and we're literally on top of the ski mountain, and we see rain coming miles away, but we know the road that we need to get out, and it's a 40-minute trip down the mountain. So guess what? I'm leaving now before the weather gets here. And you talk about a bad day. That upset some folks because I can't chance it with a ready mix truck on the side of a mountain. And so that's a good conversation to have when we talk about what happens when weather moves in, is not just do we have enough plastic for the slab, where's our emergency bulkhead, but also how are we going to get everybody off of this job site safely, especially in those mountain territories. I think it's all about communication, right? So if we don't have that communication collaboration, we're going to have a weak team, and this thing's going to fail right out of the gate. So, but a little conversation goes a long ways. talk to your producer. We're happy to send people out there, and I know that the GCs are happy to coordinate that. We just got to all get on the same page. So then I started thinking past the ready mix trucks, and my access and the placement methods. The concrete pumps is obviously a key tool for all of us. It helps all of us get the concrete placed safely and quickly, but oftentimes is overlooked when we think about the setup. I called one of the pump operators I deal with regularly, the pump companies, and just kind of picked his brain a little bit about the shortfalls that we see at the arrival on the job site. And the number surprised me on the area that required. 80 feet by 30 feet is what they are asking for, which is pretty big area. I often see them in a much smaller area than that. And if you think about the length of their truck plus the 2 mixers behind them, I mean, that's tight. 80 feet, we're going to consume all of that. And that really doesn't leave us any space for maneuvering to get into that pump. So we were talking through that a little bit, and that also needs to be not necessarily level, but flat. One of the things I see regularly when we back up to pumps is that we'll have a pump on a horizontal plane and we'll back up a hill to them. Has anybody ever experienced that? And then that shoots about 6.5 feet in the air and perfectly flat. That concrete doesn't want to come out of that truck. So what's the next natural response is, let's go ahead and get that slump up, right? Well, we don't have any chemicals here, so let's add some water. And now we've risked quality because we didn't think about that ahead of time. So that's a thing I see. Go ahead, Mike.
And that pump operator is going to be angry as can be when you spill on the sides of that chute all over his discharge pipe and the back of his hopper, and you're going to get the wrath of that guy. And then the ready mixer doesn't like it either because now he has to shovel everything across, and that's a worst case scenario.
But I see it frequently at job sites, right? That's a pretty easy one to avoid. And let's just be honest, it's hard to tell what's happening in that hopper when the hopper's at eye level. You're trying to, if that thing's too high in the air, we can do a better job there, right? So that 80 feet by 30 feet is something at a minimum we need. And the next one, he surprised me a little bit. I didn't know this, but it's a federal offense to operate a pump within 17 feet of a power line. I didn't know that. I know it's unsafe, and I have actually personally shut down jobs because the pump was too close to a power line. And even as a ready mix guy, that's a risk for me and my team because that will travel all the way through the pump and we will kill people. But we can't go up and over power lines. We can't be under power lines. We need to think safety when we start looking at that. And I had no idea it was actually a crime. So
yeah,
something that's very
Robbie,
in
the contractor world, we teach a default of 20 feet just for that insurance. And I have gotten away with it closer if the lines are wrapped, but it has to be a buy-in from all the safety guys. Because sometimes we are, let's say we're drilling caissons right on a RTD light rail or right up against power lines and things like that. It's not suggested, but sometimes you'll be under 20 where either the lines have to be dropped and basically placed underground. Power's got to be rerouted, but something that can bite people that no one thinks of is even at that 17 to 20 foot range, if you have a rainy day like today, you could arc through the air, even if you're that close. So there's even more to be aware of if you're within right at that 17 to 20 feet range and it's raining, you might want to think twice about pouring that day.
Yeah, absolutely.
But look at the voltage too. I think that 17 to 20 is like a lower voltage, not heavy duty lines that are going from substation to substation.
Yeah, those are just supply lines to transformers. Yeah. And again, these are problems that I personally experienced during the pour, right? These are things that we should have had this conversation well before. And it's that walk around ahead of start time that's where we find those things. Another common one that I have run into, even again, just today, that we really need to give that access. We need that area for the pump to sit up safely and flat, but we also now we have to provide that access to allow those trucks in and out of the pump. I don't know how many times I see a setup where we'll have a pump kind of in at an angle. The first truck gets in, the second truck gets in, and now the first truck can't get out. Well, we're not winning anything there, right? So now I've got a truck tied up, the pump's going to run out. It's just a bad situation. So we need to make sure that when we're setting up that staging area for the pump, that we're thinking about the traffic pattern again, because we need to be able to get them in and out. The idea with the 2 trucks to the pump is not so that we're unloading 2 trucks at once. It's so that while this one is swapping, this one never stops pouring, so that pump never stops placing. That's the intent. So to maintain that, we need the constant in and out of trucks. That being
Yeah, and
said,
I'll add to that, Robbie, is that
yeah.
it's like one of the other things with the continuous pumping right there it turns into a safety issue if you have one truck going, then that pump has to stop. You're causing air pockets in that pumping area, and now all of a sudden those guys that are sitting on that stinger, if they're hanging on them, they don't know when that's coming, and that kicks, that air pocket kicks, and it is a dangerous prospect if when that comes.
Yeah, and all it takes is a little forethought, a little bit of planning that, and it surprises me again how many times we'll recognize it once we get the trucks there, and then I start asking for things to be moved, and I can't get anybody's attention, and so eventually it's like, well, the pump's going to run out, and I'll have everyone's attention then, and that's unfortunate, but sometimes that's the reality that we face in these job sites. So a little bit of walk around there really helps us to alleviate that. Another thing that I've really seen a lot in, when we are really humping on a pour like that and we've got trucks in and out, is we are going to seriously degrade the area in front of that pump. If you think about a ready mix truck, when he comes into a job site and all of his axles are up, now we're excessively heavy on those drive tires, we'll really start to wear and rut that area, especially if there's any kind of moisture in that subgrade. And I've had multiple pours where I've had to shut down because the mixers are now leaning into each other, and we're going to hit the booster axles as we try to back into the pump. So with all of that in and out traffic, we need to regularly maintain the area in front of the pump. So sometimes it's, while one pulls away, we just need to get in there with some gravel or something and we'll roll that area. But it can get bad to the point where I will stop a pour because I'm not going to run into my own trucks, right? Doesn't make any sense. So that area needs to be monitored, as well as the entrance and exit roads. We really need to watch for cracking and heaving in pumping in the subgrade. A ready mix truck is about 76,000 pounds fully loaded, but when we're on the job site, we're 76,000 pounds on 3 axles. So we're really putting a lot of weight onto that small area. So, and then the last thing related to pumps that surprises me still is pump moves. We know that we're moving the pumps, but we don't communicate it to the ready mix dispatchers. And so I will, of course, that's going to be the one time in my schedule where everything lines up and I've got you buried in trucks, and then they're all going to stack up because, oh, wait a minute, we need to move the pump. And now we've created this cycle of a wave of trucks at the job, then you unload them, they're all coming back, and now we fight that wave all day long, and we lose that steady rhythm that we really want to have. But if we can have that conversation ahead, again, every time we place the order, we want to be having that conversation. I can plan for it, and I can say, at your 5th truck, I'm going to build in an extra 30 minutes into your gap. That'll allow you time to move the pump. And I understand that sometimes that changes, but at least get me close so we don't have 10 trucks stacked on the job getting old now. And that's been another problem I've seen, is now you got concrete that's old and should be rejected. So it just creates a world of problems. So again, these are real day of the life problems that I face that I think we can remedy. So, all right, I've talked a little bit about trucks. A few more things that I want to highlight that we fight on a regular basis when it talks to the day of the pour is we don't stage on public roadways, and nor should we be asked to, right? I have been ticketed multiple times, especially in some of the small mountain towns, right? They don't want a concrete mixer parked on the side of the road. And we will actually be cited for that in several areas. We need to establish that at the job site or a secondary site. What is the staging area? But that conversation has to happen well before the day of the pour, right? I actually had one here recently where we were about 4 trucks into the pour, and the police came and asked us to move because we were in the way. And the general contractor had no answer. It was, well, I can't ask anybody else to leave the job site. And it's, well, then I'm going to start sending trucks slower so that I don't end up in this situation, and you're going to have a gap at every load on your pour now, because I don't have any other response at that point, right? I'm not going to ask a guy to park in an illegal or unsafe area just so we can be ready to go when that truck gets empty. So, but still happens regularly. Also on our side, though, there is opportunity for improvement, and that's something I thought that this group, we should all be thinking about. If you see our trucks arriving, the very first thing we should be doing is remixing. I'll admit that even yesterday on the job I was on, that I had to ask the driver to start remixing, because I don't want to do that when the pump's empty. Like, I shouldn't be waiting for everyone to be needing that load of concrete, and now we start addressing the load and remixing it. So that really should be one of the first things that we do as a ready mixer. When we arrive, we need to start our remixing revs, and then we need to evaluate the load to make sure that there's no alterations needed, get our chutes hung, and be ready to go. That way, as soon as the job site's ready for that next truck, we're pouring, and we're not having all that time swapping out trucks. And that's something absolutely in the ready mix industry we can get better at. Also, you should have a conversation with the ready mix producer. We need to be picking up all of our axles as soon as we exit the pavement. As soon as we cross the threshold of the job site, all of the auxiliary axles should be picked up. And this is a training I just had with my team. There is no reason to be 37 feet long when I can be 28 feet long. All we're doing is putting people at risk. There are a few extenuating deals where we want to, stretch that load out if we got a little bit of concern about this upgrade. But 9 times out of 10, if you see a ready mix truck loaded on a job site, he should have his axles up. And if he's not, maybe point it out to him, because I'm assuming that that's what his management has trained him to do. And that's just going to keep everybody safer. On a similar note, chutes. We shouldn't be driving around the job site with our chutes extended. That's not a good answer when we're quarter mile from the washout and you ask my driver to just drive over there with 3 chutes on. We're going to stop and we're going to hang our chutes and we're going to drive over there, and we're probably going to be dripping concrete all down your job site, because we have no choice. We can't drive around with our chutes on. It's not good for the trucks, and it's a real safety hazard. We're probably going to run into something, and in a minimal situation, we're going to scratch the side of somebody's pickup, but it could be far worse, right? So we don't travel with chutes on, not even across job sites. We just need to hang them and get to the washout safely. And then the other thing that I think is important to understand in our business is that not all equipment has the same capabilities on the job sites. We recently had a pour. When I say recently, this was at the end of the winter. The pump truck made it in just fine. Well, the pump truck was able to head in, down the hill, down the snow-packed hill, and then we were asked to back in. I don't know how many people are ready mix drivers on the call today, but if you've ever backed a mixer truck down a hill, we're real back heavy, which means we're real light in the front. And if we're backing down that hill, we really almost have no steering. And especially on a snow-packed grade, it's just not safe. And in that case, we actually said, we're sorry, we're not coming in. We're not able to do your placement today. And it was a bad day for everybody. And I just don't think that people understand that there's so much weight in a concrete truck that it really alters how it can maneuver depending on the grade that it's on. Obviously, side grades are terrible for us. We just don't have the same access as a pump. So just because the pump made it in doesn't mean we're going to make it in. And that conversation needs to be had, again, before the pour. So we talked a little bit about weather. I just wanted to point out that if there's lightning, we need to fold down. And then what's the plan then? What happens when the pump goes away? Do we have an alternate method of placement? Because if there's lightning and we're back up to the pump, it's time for my guys to leave also. Now I can pour, but not attached to a pump that's got a boom in the air. We're gonna pull away from you, plain and simple. So, and we talked about the cracking and the subgrades and stuff like that. So it's just, these are all real problems again that I continually experience during the pour. These trucks are heavy. It's a constant problem. And let's talk about it and get it fixed. So this one, I had to share this picture. The washout is one more big fight that we have the day of the pour. This was at the end of the pour. I got the call of, what are you guys doing? and we were accused of unloading trucks in the washout, which should never be a thing. Washouts are washouts. They are not waste disposal sites. In this case, there was a bunch of base material that had got dumped in there, and unfortunately we covered up with concrete. But so that's a conversation to have and make sure everybody is on the same page. And I had that conversation with my drivers and my team that we don't ever dump concrete in this washout. This should be wash water. We're washing the upper hopper, the collection hopper, and the chutes. Everything else stays in the truck. We need to take it back to the ready mix plant and dispose of it in the appropriate area. Again, we can't.
Can you just say that one more time, Robbie? Just say that one more time. What's supposed to go into the washout?
So wash water from the hopper, the collection hopper, and the chutes. That's it. That's all that's supposed to go in there. That's why it's called a washout, not a dump site, right? So anyway, so we see that as a regular problem. Getting back to the traveling, I can't travel dirty. I won't travel dirty. I'm going to clean out on your site somewhere, and we need to figure that out ahead of time. I do carry disposable wash bags that I will scrape down and rinse into, and I'll leave that there for you as a present to clean up later because I can't travel dirty. So there are some solutions to that. Regularly, I see concrete pumps not able to get to the washouts because they're too high. A pump has a much lower wash area than a concrete mixer. And really just where are they positioned is one of the biggest things that I see us. We have a job on the side of a hill right now where we're having to go down a switchback road and then back up another hill and then try to turn around to get to the washout. And it's just eating everybody's lunch. There's got to be a better place to put that, right? So if you ask me, if you're a customer of mine, and we can have that conversation, I'll advise you on where to put the washout if that's a concern at all. But really, I mean, let's get it to where it doesn't impede traffic. It doesn't impede access to the pour location. Like next to the pump is not good. We need it far enough away so it doesn't impede that. But we need it on the traffic pattern and not out on some leg somewhere in the job where we have to go and turn around and come back and then get back into traffic again. So there's a lot of opportunities, I think, with the concrete washouts. So, all right, and then this is my last producer slide, then I'll get off my soapbox of day of the life problems. So a common occurrence where I think we have some opportunity for improvement is the concrete testing. And we really run into misaligned timing a lot. We frequently have trucks loaded and we say, oh, the tester's not there yet, just go ahead and hold the pour. I'm thinking an hour in front of that typically. I'm loaded an hour or an hour and a half sometimes in front of when the expected arrival time is. So once the trucks are loaded, there's really not a lot I can do. I might as well get them to the job site. They shouldn't sit with me and get old. At a minimum, they should sit out there and get old. We just need to make sure we're all on the same page. And as a producer, we can be guilty of that as well. If we push a pour, we need to communicate that, right? And maintain that schedule throughout the duration of the pour. We see the same problem with pumps too. Pumps get pushed, concrete trucks get pushed, testers get pushed, but we don't all get on the same page. And then one of the three people don't show up and we've got a problem. But most recently, the biggest problem I see, or one of the biggest problems I see with misaligned expectations is over-testing. We get calls frequently for 10-minute spacings, send them as fast as you can, knowing that we're going to have 4 separate agencies testing the same load of concrete before we ever start placing it. And if you think about that, even if it's 3, if it's the ready mix producer wants a sample, the QC wants a sample, the OA wants a sample, we're like 30 minutes into this load before we've ever started placing. And if I've ordered 7 to 10 minute splits, I've got 3 or 4 trucks stacked up behind it. And we want to test the first 3. By the time I get to the 4th truck, he's been sitting on the job for at least an hour. And we've got old concrete that's now out of spec, and we're having debates about who's paying for it. And so a lot of times I think we just need to get together as a team and say, do we really need 4 people testing this load? Or can we all just get together, let one person test it, and we all make a decision based off of that good test? Or at a minimum 2, let's test the front of the load as soon as he gets there to make sure it looks reasonable. And then let's get pouring so we can get our acceptance test from the middle of that pour. But testing 4 times is is just killing us as an industry. And then also testing every load for 100 yards straight, it just kills a pour. It hurts everyone. It hurts the producer. It hurts the placement guy. We honestly have reached a point of over testing, in my opinion. And then the last two things on the testing front, what happens when we get different results? QC and OA have a different result by more than 0.5% on the air or more than 1/4 inch on the slump. That conversation should have been had at the pre-construction meeting, at the pre-pour meeting. What are we going to do? In my mind, the answer is simple. We're going to recalibrate our equipment and we're going to both retest it again. But it's amazing how many times in the heat of the moment, that's not the answer. Now it's become a fight, and it's you're paying for this load, no, you're paying for this load, and a bunch of F-bombs get dropped and nothing gets resolved. Let's just define that process up front. It's no offense to anybody. If somebody asks me to recalibrate my meter, I'm going to recalibrate my meter. I'm just going to double check my equipment. And if we can't figure out why we have differing results, we need to continue the conversation and be collaborative. It's not an attack on your ability to test concrete, or it shouldn't be. And then that's where we need the decision maker, is when we get to that point, who is making the decision? And that needs to be decided well before the load is being rejected. So from my perspective, these are some of the real struggles that we face. And then we'll hand it back to the flatwork team.
Robbie, before Michael takes on a conversation about the flatwork, if you don't mind me just making another statement in regards to your comment about recalibrating the equipment and making sure everybody's on the same page. It would be my recommendation from the industry is to understand the difference between calibration and verification. On a site, it is good to verify your equipment, especially when there's differing results. Have that little air bomb, that 5% air bomb, drop it in there and verify that both of you guys have the same results with that equipment. Because yes, calibration is good. It should be happening every 3 months for an air pot, but it does take even more time out of the job site if you're waiting for that between loads. So if you're able to verify using simple equipment between all of the equipment for all of the QC, the OA, and everybody on site, it does go a lot faster, and it's a simpler and easier accepted value to understand, okay, are these values correct?
Yeah. And, on that kind of that conversation, let's check the unit weight versus that air meter as well. And let's evaluate the results to see if there is a problem in the testing method, or do we actually have material problems? And it's amazing how many times that seems like an attack on somebody. I was at a project here in the middle of the summer where results were questionable. My air didn't match theirs. We were recalibrating meters and people are upset. And I said, "What's your unit weight?" And that was taken as a personal attack. No, it's just a number, and it's going to help me validate, which one doesn't make sense, the weight or the air? And we just got to start being collaborative on those conversations. It's not a fight, and we'll talk more about that with CTAC. It's all about making quality concrete. So, okay, Mike, back to you.
Probably that's a really good point on checking unit weight. If you're consistently checking unit weight, especially for air and trained, and all of a sudden the weight's out of whack and the air's out of whack, it's probably a problem. But if the unit weight is still what it's been all the time, but now you're getting an unusual air meter, which is a sensitive tool, the air meter is probably wrong. It's hard to mess with the weight. I mean, unless you really hit it hard with water or something. I mean, it's related to flatwork finishing, particularly when the finishers are pretty busy. It's great to have that, again, the mock-up, just to confirm that mix is doing what it's supposed to, and a low risk to resolve things ahead of time. 4 to 6 weeks out, have a rolling schedule updated weekly. And then, again, as Mike said, double check that day before. It could be the MEP guys never got their inspection. You don't want to find that out when there's 4 trucks lined up and you got a pump already arrived, to find out there was a failed inspection. And then backup plan for all the equipment, whether that's a bucket to back up the pump, extra vibra screed, extra vibrators, all these mechanical tools have a point where they stop working as expected, or maybe need plan B. So in low and light carbon concrete, or even just 1L concrete, there has been a recognized need to use countermeasures earlier than you used to have to do. That's probably going to be fogging. That's not direct application to the slab, but kind of in the air to increase humidity, upwind, more evaporation reducers, more finishing aids, and starting it sooner. This is a Kestrel device. Hopefully everyone's familiar with that. It can be used to measure your on-site evaporation rate, to just monitoring with an infrared thermometer on the surface or with a probe inside the concrete. Something that the delivery temperature is not going to hold for very long. You can get an app. This is a Master Builder's app. We're showing tools here, but we're not endorsing anything. We're just saying that's the kind of tool that you would like to have available to continuously monitor. The app will give you what your zip code is doing. It's not going to give you what your job site's doing. Kestrel would be more of an on-site confirmation of what is expected, but the app's really good at forecasting so that you can know, hey, we've got wind coming in, or increase in temperature, the evaporation rate's going to change, or tomorrow looks terrible, or anticipate needing more countermeasures.
Yeah, Mike, on that environment thing, I think one thing that gets missed a lot that I just want to highlight is that concrete structures are really based on that microclimate that they're exposed to. Because there can be a wall that's dividing the slab from a different environment, and really what matters is that area right above the slab, right? Because that's really what we're talking about in evaporation rates. And so the Kestrel is a great tool because we're measuring the environment just above the slab, and that's where it matters. Mike Eads had a good comment about putting up some wind blocks, some tools that he uses, the construction fence to change that. And I think that's where people get missed, is because they'll put the app up and they'll look at their zip code and say, oh, it says I'm good. But in Colorado, we all know that environment can change in 10 feet, right? It can be the other side of the wall. The north side of the building is dramatically different than the south side of the building. And so that's what's important, is we measure at the top of the slab.
Yeah, and once the hydration process kicks off, that slab's exposed to the sun, or it's a cool day with cloud cover, it's a dramatically different surface as far as how much it's heating up and then reacting as a result. A lot of success in early placements before sunrise. You're getting out there and getting a lot of concrete down before the sun comes up, and more importantly, before traffic starts messing with your cycle times on each ready-mix truck. Contemplate adjusting seasonally. I mean, probably preaching to the choir a lot of these things, but just kind of a reminder sometimes, things to think about. I like putting maturity sensors in the last panel of the day. If critical lift's coming up soon, it's a good double check just in case that cylinder didn't get taken care of as well as it should have. And then hearing nationally that accelerators are getting more common even in non-winter conditions, just to avoid a condition where the surface is hardened or losing moisture, so it's seems to be hardening while the bulk of the body of the slab is still not hit initial set. And don't buy the cheapest 4,000 in the market. Like a decade ago, all that mattered was price. Now quality is way more important because of the we're running low on the best sources of aggregates, and especially sand in a lot of places. I'm not sure what's happening on the western slope. I know I was in Florida, it was pretty much all manufactured sand, and it doesn't pump, it doesn't finish the same way as natural sand does. So I know that aggregate suppliers are frustrated that, hey, valuable land is riverfront property, which is where all your good sand's going to be, or good aggregates, and residential values of that are getting developers to buy that property before a quarry can be put there. Again, don't bless the slab. Evaporation reducers aren't supposed to be trialed in. And the caution against getting on a slab too early if it seems like if it's hardened, but just be careful that we don't seal the slab prematurely. Some tools. This is an article. I worked with the guys at SSI to publish an article on Concrete International last month. And there's a QR code for that. CRMCA has a good exterior flatwork. The one that I worked on was primarily focused on interior flatwork, hard troweling slabs, but both good resources. So final curing, even more important on a 1L or a blended cement. 2 coats of spray applied at 90 degrees to each other, and they'll go in north-south and then east-west to try and get good distribution. Really just trying to keep the moisture within the concrete so not lost to evaporation. Mike, do you want to add any comments on that or keep going?
From the first presentation, everybody probably remembers on the call, I'm pro spray cure because I've given examples of dead of winter, inside parking garages on sloped surfaces, how I'm going to run that water down there and keep it from freezing. And then I have to collect the water that pools at the bottom because it's a stormwater issue because of the alkalinity of the water at that point. So on this, we see it, finishers, at least in our experience, this seems to be the part that they don't take as much time on, unfortunately. We'll see a good finish. We'll see a good vibrate. We'll see good techniques for going power trials in an X or a plus across the slab to make sure you're meeting your FFFL. And then it seems like the end of the day, they have the new guy with the can out there spraying, and he's either overlapping, which can cause problems with dissipating for floor finishes, or he's just not putting it on every part of the slab, so you get some tiger striping going on, and it there's nuances with that have to be trained in. But it's I think with the discussions around 1L and the need for more drastic curing, people are starting to pay more attention to that, luckily.
So not talking about overcosts or anything like excessive costs or anything. Is it a problem for overcoating using the sprays? Because we keep talking about the 2 coats, 90 degrees an angle, spray one direction, then spray the other direction. But is too much, or does it affect that curing as well?
In my world, too much can be very problematic. So they have a square foot per gallon that's listed on the can. So if you were to two direction spray, I would cut that in half. So let's say you're 300 square foot per gallon on requirement. I'd want to go 600 and 600 in order to make sure I'm not caking that stuff on. It's not so much a cost. I would say most cure material is cheap. It's one of the lower budgets in my books. It's not an expensive product. What can cause concern is if that doesn't dissipate. So if it's a dissipating cure and you put 2 or 3 layers on and it doesn't dissipate, the flooring guy is going to come in and say, I want that chemically removed or blasted. And a citrus wash is usually your solution, that you will hook on a citrus compound onto a power washer and you'll power wash that off. Well, now you've got the other extreme in collecting water runoff. Is now, instead of an alkaline surface, you now have a basic solution, which is more acidic. And you're going to, that's still a stormwater issue. You're going to be at like a pH of 4 dealing with that stuff instead of 7 or 8 where you need to be. So it can wreak havoc on that. So if you have a job with a lot of carpet, if you have a job that's got a lot of those kinds of floor finishes that aren't as critical, or there's a tile bed that they're going to put tile down, so you get a mortar bed underneath it. It wouldn't be as concerning to me, but some things that are coming to mind immediately are ultra thin vinyl applications, wood floors, those kind of high end finishes, any kind of if you're doing like a epoxy coat on a floor, those would, or a traffic coat, those would be a concern, because the Division 9 subcontractor for flooring can come in and go, yeah, I'm not able to bond to this surface because of X, Y, and Z, and it can be the carrying compound. Then they will hit everybody with a colossal back charge to get that stuff removed.
Yeah, that's part of the pre-pour expectations. I think the 90 degrees is more about getting even coverage, because it doesn't take much to get one of those tips to not spray evenly.
Yep.
So I've been encouraging contractors to test their own floors. We're not emphasizing price, we're not endorsing anything, but just to give some ballpark idea, most of these devices are about $10,000, whether that's the dipstick, the F meter, or Axiom 1155, or even better, which some teams are doing, is run the F meter or dipstick and then scanning also. What that will give you is basically an insurance policy that there's probably going to be some high points and some low points in that slab somewhere, to see where they are. And then once the shoring is removed, if you scan it again, then you can see where is purely a function of deflection, or if it's slab on grade, purely a function of curling and not the finisher's skill. Because that seems to be the debate all the time, is especially when the flooring contractors get there and look, they think they're getting an 8 and 10 feet gap between the straight edge. That's those F numbers and the gap under straight edge don't always correlate perfectly. And if you're talking about the test hasn't been done within 72 hours, there's a whole test on compliance versus it didn't look this way when I walked away from it complication. So that's one way to avoid the dispute, is to just have your data and submit it and keep moving, and also give the ability to confirm throughout the building that you're meeting the overall. If you have a low single slab, it's not the end of the world, as long as you know that you can hit some higher numbers as you go. I think this is going to be one of the themes of this program is the initial curing of concrete cylinders at 60 to 80 degrees. Unfortunately, the image on the right represents what is happening most of the time in the industry, between the cost of the setup of the proper tank and the maintenance of the power provided to it, or if it's a water tank, the maintenance of the water to it, and if there's a heater, maintaining that power, whether it's off generator or temporary or permanent power. It's an ongoing challenge, but it does need to be addressed project to project. On that specific topic, I've been asked to work on an article for Concrete International, and to get feedback from someone like Robbie and the Red Mix producer, a good relationship in the Midwest, and kind of say, what do you do when you're recognizing that, hey, the cylinders are being left outside, this is not what's supposed to be happening, to what steps to take, I guess, beyond the pre-construction meeting that says, we're going to have a plan. Let's figure out what the plan is. And if it's too late for that, as you're already seeing that it's going sideways.
Yeah. So, and we're going to talk more about that towards the end of the presentation, right? But I mean, the association has a couple of tools. CTAC currently is a method to evaluate the testing of plastic concrete and also the initial curing conditions. And then there's more on that here coming up. But it's just a conversation that I have to have with GC pretty regularly about the testing reports indicate that the cylinders are being handled appropriately. And in some situations that conversation happens enough times that I just finally say, I am absolved of risk here. You guys, good luck, because you're not doing what you're supposed to be doing. And then I also do case studies to try to demonstrate the impact of those improper curings, which is what we're going to cover next, is that, hopefully educate the industry about this is how important it is. So that's what I'm doing here. But really, we just go to the GC and have a conversation. And then with that, am I next now? I think that leads right into the initial case study. So let's talk about why this is so important, right? So ASTM C31 are the rules that govern initial curing. The highlighted points here are really the things that I see where we fail regularly on those job sites. So these are the things that I'm typically talking to the contractors about. Are we maintaining the 60 and 80 degrees for that initial curing period? And regularly the answer is no to that. Almost, I would say more than it is yes, the answer to that is no. Or we don't know because we didn't record the temperature. That is a very common problem. And we're guilty of it too. We're not perfect on the ready mix side, but also I'm not evaluating acceptance of the material. So it's not as important for me to do it as it is for the project quality control. That is their job, and that needs to happen. That's a requirement of the test. So I see that one regularly. We talked about in the planning conversation in the previous call about making sure that we have access to pick up cylinders. 48 hours is the maximum amount of time to have cylinders placed into their final curing environment if they're used for acceptance testing. And how do you do that if you pour concrete on a Friday before a holiday when we're closed on Monday? It just doesn't happen. But regularly, those cylinders will get turned in and broken and reported as low concrete. No, they're not low strength concrete. They were left in the field for 3 days in 100-degree weather. That's a problem that occurs over and over, is that we start evaluating the structure based on bad testing. So, and then a new one that I think is getting to be a bigger issue is we just talked about the requirement for accelerator with 1L cement. Well, these cylinders can't be transported for at least 8 hours after final set. Well, when is final set? And what is it now with 1L cement versus 1,2 cement? So we can't cast them and take them home, but we can't leave them out there for 3 days. And unfortunately, that is a conflict of schedule for a lot of people, but it's the requirement. So we need to figure out how to do that. And it's more important now that we do that than it ever has been. And then the last thing is the transportation. And believe it or not, yes, I do see this. I have one job right now where cylinders are regularly being commuted from this side of the mountain to that side of the mountain to be broken, to be cured and broken. And that's not in compliance with the standards. They can't be commuted over the Rockies to their final curing environment. So, but these are all existing problems that we've had for the last, I've been in this business for 25 years, and this problem, all of those have existed for the last 25 years. So that's not new, right? What's new is that we've changed cement for the first time since I've been doing this. We've really made a change to cement. And I think Kevin Kane presented on sustainability and maybe why we made that change. But the summary, right, is we changed cement to lower carbon emissions in the cement manufacturing process. And what we did is we started adding additional limestone to reduce the amount of heat required, the amount of clinker required to make a ton of cement. So that's a pretty big change. I know when that first happened, it was like, well, this won't be very noticeable. And in a lot of aspects, that is accurate. The strengths, we can perform the same as we ever have, as long as we quit taking the shortcuts that we've always been taking, right? That's the key to making 1L successful. So kind of looking at this over the last 2 years, trying to understand what's happening. I have been called to the table more times in the last 2 years for low strength evaluation than I have in 25 years of making concrete. And that's telling, right? That indicates that there is something to the 1L. And I am not trying to blame 1L for the problems. What I'm saying is it's different, and we haven't reacted as an industry on how to appropriately handle that. What we have found in, I would say, 99% of the cases that I've been called to the table, that we didn't have low strength concrete, we had low strength cylinders. And now I'm trying to understand why. So we did a case study here that I'll get into the data on, but my first thoughts are what's different with 1L. We talked about we have some of these existing issues. So to elaborate on that a little bit more, existing issues with concrete is that we need enough moisture to hydrate the cement particles. And if you think about a 4-bay cylinder, it's a very small specimen and there's not a lot of water there to begin with. And so it doesn't take a lot of heat and evaporation to lose the water that's in that small specimen. So it's easily influenced by the environment. And if we have rapid moisture loss in cement, the hydration will stop and we will have resulting low strengths. High initial cure temperatures already accelerated that. So if we expose that to high heat, we're going to have that rapid moisture loss. We're going to have rapid hydration anyway, and then that strength issue is going to be compounded. And then this is where I get a little bit into the weeds, but the C3 ions can absorb onto the surface of the C3S, and that can hinder hydration. And that was already existing before, right? And now we start to look at how did the increased limestone affect these things? Well, we know that it's a fine absorbent material that we've placed into the cement, and so it's consuming water. So do we have enough water for hydration to begin with is a good question. And if we're not protecting it and we're losing additional water to limestone throughout the, initial curing process, if it's absorbing any water and we're losing water to evaporation and hydration, there's just not as much forgiveness in this concrete as there was. We know that the clinker grinds are finer, so that there's going to have a higher initial cure temperature, a rapid set of finer cement particles. That's how we make it go faster, is to grind it finer. And we know we're doing that to offset the reduction in clinker factor. So, and then I don't know that we've done enough testing to see what are the gypsum to clinker ratios. And this is where we get into kind of that C3S, CSH development. It's different now, and I'm not the chemist to say that what we're doing is right or wrong with 1L cement, but I know we've changed it, and I think that we could have some abnormal dissolution affecting that cash development in hydrating cement. So that's where I started to think about we need to try to evaluate this, and we need to understand what the issues are. And honestly, what I learned, that's a lot of what I've already said, is for one, I learned that we're not very good at testing concrete. So the very first step is we said, let's get together as an association, as an industry, and let's just have everybody test the same load of concrete, and let's see what the results are. And we're going to intentionally put some specimens out exposed to erroneous conditions and see what happens. And we did that in February and July in Western Colorado, and we had about 15 samples of the same load of concrete, all by various certified testers. And the results of that were pretty telling. We got it back into the lab, and you can see, so 100% is the control. And we had a lot of varying test results, but these ones here at the end that are significantly lower were exposed to high temperatures. These are initial curing temperatures on the bottom. So we saw that high temperatures really impacted the 28-day strength of the cylinder. So we're about 75% of control here. We're about 93% of control on this one. And we actually did put one set out to freeze in the February test, and 19 degrees obviously killed the strength development of that concrete, which isn't a surprise. But what we saw is the rest of these are the variability in testers. So from 99 to 78% and 97 to 81%, that was the same concrete being tested by different people. And so that really didn't do what we intended to do. We intended to evaluate, has the protection of cylinders changed? But we found out that there's just a lot of variability in that by itself. So I think it's telling. It's worth noting that just right there in a controlled environment, we had a lot of variability in what was reported back as initial curing environment, and we had a lot of variability in the compressor strength, all of the same load of concrete. So right there, we need to get better at that is one thing, but it still didn't answer the question, right? So we came back again and we did another test. And to eliminate some of the variability, we shortened up the list of testers, and we said, okay, we're going to have, we cast 85 cylinders, and we had, for my situation, I think, doing the first lift of cylinders, and another tester was doing the rodding, and another tester doing the second lift, and so on. And that way, I had the same roll in every cylinder that was cast, and we had all of them broke by the same compressor brake machine, by the same operator, to really eliminate the variability in the operator and just evaluate the material. So, moving into that data, this was the same load of concrete. It took about 3 wheelbarrows to cast the 85 cylinders that we made. And what we did was we put them at very controlled initial curing temperatures for the first 24 hours. So here you can see we had a 60-degree set, a 73, an 80, 100, and 120. And the reason we have 73 is that's the optimal curing temperature for concrete. That's what we put our cure tanks to, right? That's the best temperature that concrete can cure at. So we wanted to see what happens if we go cold and what happens if we go hot. We knew from the previous test that hot was the biggest impact. And then we had actually a really good idea, and it wasn't mine, so I can't claim it, but well, let's change the humidity in that first 24 hours as well. So the orange bars here represent what we call a dry cure. So that was cylinders cast in plastic cylinder molds with the lid-ons, but nothing to protect them from moisture loss. Okay, so just like you see on a job site every day, cap them, set them aside, put them in a cooler maybe, cover them up with a cardboard box to protect them from the sun. But they're in a mold, lids on, so there's no moisture loss there. And then the blue ones are cured in that same temperature, but in 100% humidity. So in the cylinder mold with the lid on, but underwater. And so that's the difference between these two test methods. And it really starts to show, if you look, the 73 degrees is control, so that's 100%. And in this test, that was about 6,000 PSI on what we would sell for a state mix concrete, Class D concrete. So as the temperature increased, we started to see some strength loss. But you can see here on the ones that were cured in a moist environment, we lost 4% as we got up to 80 degrees, which is the upper limit of the spec. We got up to 96% at 100 degrees. And then we were still at 90%, 89% at 120 degrees for the first 24 hours. And that was for the entire time, right? For the entire 24 hours. This was in an asphalt oven, so we set it to 120 and it stayed there. It's not like it peaked at 120. So it was interesting to see that we really didn't have that much strength loss. But then when we look at the orange samples of the ones that were just set in the molds, by 80 degrees, we've already lost 10% strength versus the 4. And by 100, we've lost 17. And 120 degrees, we've lost 31%. That's 69%, I think. I can't read it, but I'm sure that's what it was. So 31% strength loss, just really from moisture loss in the cylinders. Again, these were all the same load of concrete, and I think we eliminated all the variability we could in the test. So I think what this tells us is that it is super critical that we maintain the initial curing environment. This is the first 24 hours on the job site, and I guarantee you, if Mike gets a 69% at 28 days, he's calling me, telling me this structure's got to come out, right? But the data indicates here there's a good chance that concrete is still good concrete. It was just mishandled cylinders. And I think we need to get this out in front of everyone to see this kind of, I mean, that's 2,000 PSI difference between what was cured properly and what wasn't. And that in almost every situation is removal. But why are we removing good concrete from our job sites just because we didn't handle the 5 cylinders correctly? So that's the study that we did, and I think it was really profound information that we need to share. And this is just kind of summary of that. It was about 1,800 PSI at 28 days. We did core a lot of these structures throughout the last 2 years, and almost every time the cores came back 20 to 40% higher than the 28-day cylinders. Well, that speaks for itself. That says we have bad cylinders, not bad concrete, right? ACI says that concrete cores are only required to make 90%, 85%. CDOT says 90%. of
85.
Yeah, 85% for ACI, 90% for CDOT. That's because it's so easy to damage a core, and the concrete in place is not expected to live in this perfect condition environment for curing. So when your cores are exceeding your cylinder strength by 40%, that really indicates that you have bad cylinders, right? I do think, and I'm not trying to pick on 1L Cement, but I do think that 1L has contributed to this issue, and I think it's the same issue we see when we're placing slabs. You know, we talked about curing our slabs and being aware of the environment and how much more cracking we're seeing and how important evaporation rate is. We changed the evaporation rate expectation for finishing a slab. Well, the cylinders are experiencing the same thing. There's moisture loss with 1L Cement, and if we don't protect it, we're going to have problems. And I'm not saying that we need to rewrite the rules. I'm just saying we need to start following the rules that have existed for a long time. And then the last thing to close out with this case study, if you looked at the ultimate strength of that 6,000 PSI concrete, that's for a 4,500 PSI spec. And that's what I sell regularly because I'm regularly asked to participate in low strength evaluations for mishandling of cylinders or things like that. Remember, the intent of 1L Cement was to lower carbon emissions and to lower the global warming potential of my concrete mix, right? Ultimately, the concrete that is delivered to the job site, we're trying to lower the carbon emissions, the global warming potential of that. Well, what happens when I start having strength problems is I start increasing cement content. And so now, instead of lowering the global warming potential of the concrete that you're receiving to your job, I've added cement, which is the highest carbon emissions product I can put in it, and my GWPs are going the wrong way. And so we're not even getting what we desired to get by adding 1L to the industry. So let's handle the cylinders correctly so we can really evaluate the concrete, lower the over design, and get a lower GWP, and then we will be actually winning in the global warming initiative. So, and that is what I have for that. Mike, you asked me about what do we do, how do we evaluate it? CTAC is currently how we evaluate it as an industry. So that is the Concrete Testing Adherence Program, collaboration program. And currently there are 9 associations participating. We have more onboarding all the time. Colorado is a leader in this. And basically what it is this is a way for anyone that is a certified tester to evaluate the testing that's happening in the field. And on the right, you can kind of see some of the results of that. We had 2,400 observations in 2024. We're about 1,700 right now. So we're a little bit behind last year, but this is one of the tools that I think we need to push as an industry. And we need to make observations about what is happening at the testing and the curing of the concrete because we don't want to make poor decisions based on bad testing. And unfortunately, it's just the way our industry is that, let's be honest, a concrete tester is kind of an entry-level position for a lot of folks. And we need to make sure that they understand how important it is that they do their job correctly so we're not making those bad decisions. And this is a good tool for it. The issue I've had with CTAC is it, again, gets to be an attack. It gets to be a debate. If I make an observation, it's not an attack on you or your company. And please make observations on me and my team because it's an opportunity it's an observation. It's an opportunity to learn and improve. That's the whole point in this. And that's what CTAC is, and that's what we have currently. But what CTAC has told us so far is that initial curing is a problem. The data that we are getting is that we are not doing a good job. When observed, we're not doing any of the things that we need to do to protect the concrete cylinders. And we just talked about how detrimental that can be to the strength of the cylinders. And ultimately, that can create real problems for the project. So the CRMCA is now working on what's called Cure Comply, and we're introducing a new tool that is a little less focused on the actual physical properties of the concrete. And so maybe it will be less of an attack, less of a personal attack on maybe somebody's ability to do their job, and more just an observation list of specifically the initial curing of those concrete cylinders. And what we talked about is that that makes sense to set up at the pre-construction meeting. We all have access to it, right? Me, the general contractor, the third-party tester, and we can all make observations of the cylinders, and it just becomes a log of information that we can all look at together and say, is this a problem? Or like you asked earlier, how do I handle that? I'm going to put it in the log. Now I'm going to put it in cure comply, and we're all going to see it that, yes, again, cylinders are out of compliance, out of compliance, out of compliance. Well, now it's time to make a change at the job site. Somebody has to make a change. And it's important that we do because, like I say, it's thousands of PSI difference. So, and that's what I have. So I think, Mike, is this one back to you?
Yeah, this is my Captain Planet slide. It's kind of the first time I've ever seen an example of collaboration where all five basically have a ring and put them in and they create Captain Planet. So I know it's a dorky example, but it's one I think of my earliest memory of collaboration. It just goes over all the points that we were talking about. If all five, for example, on this slide are talking to each other and making it happen, it's kind of that dream scenario where everything comes together. You're minimizing issues on the side. I'm not saying you're going to fully eliminate them because it is construction. Things are dynamic. But if you're giving it a 95% probability, you're going to have much more success. All the players on the job are going to want to work with you again if they see the collaboration going on and they see that someone cares. They're keeping their best interest in mind. So the pre-construction meeting is really where it's at. You can't exclude anybody. So I got to bring a Robbie in, I got to bring a Mike Hernandez in, I got to bring, who's going to be physically on the job site, representing every group who's has some stake in the game, so to speak. Just communicating like everything that could cause any kind of change. So we talked about who has authority adding trim water, who has authority to reject a load, who is going to make the call when the cure tank doesn't show up or somebody's doing it improperly. Mock-ups, this one kind of allows everybody to weigh in, physically touch it, dabble in it. I take it a little bit beyond that because I need to know my mock-ups, what's the look and the finish, like the aesthetic of it, and is it natural light outdoors or is it artificial light indoors? So a lot of times with my mock-ups, I got to be selective on where I put them. A tip that I've shared in past presentations through CRMCA was try to do them in a back of house room, do an electrical room, do a mechanical room, something that may have a louver where you get natural light on the outside, but you're going to be artificial mostly. And you'd be surprised at the drastic look and kind of the color appearance, even with a standard gray, what that effect can have. And then you're in essence giving the owner something a little bit better. So it's not a hard sell. When you're saying, hey, I'm going to do a decorative concrete in your electrical room, that's I've never heard any owner say, I hate that idea. That sucks. They're going to say, sure, why not? And then you always have something that's permanent that you can go back in that room and reference when disagreements occur, which they ultimately could. You always have that permanently in place that you have something to go back and keep everybody playing by the same rules. Pre-pour huddles, morning meetings. This is something that if you want to really effectively push the communication side, do it daily. Don't just have that one meeting and then a month later everybody forgets what you talked about and then you start the job. We usually bring our guys in 15 minutes early and we do a huddle. It'll be talking about what we got during the day, what are our activities, what are we going to be working on, and then what everybody else is going to be working on. When you deal with jobs where you have just-in-time deliveries, where you're going hour by hour with a crane, zero lot line, this becomes a lot more critical. You will actually schedule by the hour. So this would obviously be a huge help, like Robbie was talking about. If you are letting him know when that pump is going to shut down and relocate, if you're doing hour by hour schedules in a huddle in a morning meeting, that should be a pretty easy question to answer. The order in which things are completed. So this is a big one in the contractor world. We have a 7-layer dip, and it's got to go in that specific order. You should know your trades before and after, and concrete is a major component of that. But I can't be successful if other subs are not before and after me doing what they need to do. So is the dirt grade at the right elevation? Is it packed properly? Is it within 1/10 of a foot on the grade? Have the inspections been passed and approved so I can actually go? Then we do our rebar and concrete thing. And now after, the waterproofer is going to come to me and say, okay, can I adhere to the concrete? Did it dry out enough? Is it smooth enough that I can adhere to it? The flooring guy comes in after that. Did you put too much carrying compound down? Do I have cracks in the floor because you didn't put carrying compound down and now I've got to do remediation and repair or some kind of seal coat? Those kind of things really come into play. So our work is not finished when we pour the concrete. We think it is in our industry, but 6 months to a year later, we're dealing with deflection on decks, dealing with any kind of hardened concrete issue. A lot of times in my world, it's damage. People think you can just treat concrete rough. Nobody thinks to cover it for 6 months and protect it. Unless you're dealing with decorative, that's usually the world that you see that. Or if you're dealing with polish and you have to grind that surface and you can't have things spilling that penetrate that concrete. And then when you grind it, it's even more apparent. So those kind of conversations, making sure that everybody knows to respect each other's work. 3D drawings and 3D models, having the current drawings even. I've gotten addendums or issue for construction documents and the rules changed. They might have increased a mixed design from 4,500 to 5,000 PSI because they finished their design. It may not be clouded, and holy cow, that's a big miss. So making sure all that stuff's incorporated. 3D models, it's our way as contractors to connect the dots when design professionals get a bad rap for not issuing drawings that are complete. Now, let me be fair to both sides on this. The owner is not paying them enough money to complete those drawings. So it's easy to say to the architect and engineer, you didn't draw all these details, you haven't completed this, you haven't shown all the information that I need as a contractor in order to build this thing. And they're going, we only got X amount of dollars to take it this far. And the owner's saying, yeah, that's enough spending money on these drawings, putting them together. So the industry solution has been to hire a 3D modeler that connects the dots. They basically can figure out the details by pulling in the model and connecting them, so to speak. So before you go too nuclear on your designers, know where they're coming from. A lot of times they don't get the proper funding they need either. Now, that's not to say that there aren't corners being cut, is the best way to put it, but it's not as one-sided as a lot of people think. A robust QC QA plan, so having that in check, and you do pre-pour, post-pour. That's something where Mike had a link to. I use my own in-house. It's something that I've built over the years that has just stemmed from experience. And it's something that we refine every year because the rules change and things change. Code gets stricter. Rate of pouring, I beat that one into a fine paste. Everyone's heard that now. Everyone needs to know that rate of pouring. If you don't know, then odds are you're missing a piece of the pie that could compromise somebody else. And then this is one that I battle with. Robbie gave an example of how long does something take? I'm dealing with travel times and then we're waiting for somebody to show up and things like that. What's becoming more common in my world is how long do forms need to remain in place? And 301's really kind of doing us contractors dirty with it needs to stay on until it achieves 70% of strength before you could strip the forms. That never used to be something that was taken into consideration. It's something that is become normal now. I live and die by ACI 347, which is the formwork ACI code that says you can remove forms in 12 hours. And as long as the concrete doesn't deflect shape or modify shape, then it is acceptable. So there is a disconnect between 301 and 347. So I try to present that as my argument back is the formwork code says I can do this based on your table 3.1 in there, So I would like to meet in the middle, and I usually use that as a poker chip. So more times than not, it's acceptable, but every now and then I run into somebody who likes to stand their ground on that issue. And with that, that's kind of a summary of updates and our presentation. So our contact information is listed there for each of the speakers. Does anyone have any questions? And DJ JT threw down some hot music for you guys to think.
I'm gonna take a look at that 301 reference just to double check where that's happening.
I'm sorry, Mike?
I'm gonna take a look at that 301 reference to see where that's occurring.
Yeah, that's I didn't get the exact section, Mike, but probably 2 or 3 engineers in the last 3 or 4 jobs I've done have referenced 301 that is going to be the rule.
Thank
Whereas
you guys.
I love ACI 347 because that's it's much kinder to the contractor.
All right. Thank you guys. Any questions from the group? Please do speak up if you have any questions. If there are none, I will thank you guys for all joining us. And there was some great conversation between you guys, Michael, and Robbie. Much appreciate honestly the candidness that you guys spoke with today. And if you guys couldn't tell, it's almost 4:00 here in Mountain Time. And there was a good reason for us to make this Collaborating for Success a 2-parter because between both the parts of the conversation, we've spent pretty much more than 3 hours on these topics, and we could probably go for another 4 hours if we really wanted to talk and really dive into each and every one of these items. So I do appreciate you guys. If you guys want to reach out to any of us, our emails are right there. Please do keep in contact with us and keep up to date with CRMCA events. If there's any questions, please speak up. Otherwise, we'll close it out. And again, I appreciate your guys' time. Thank you very much.